Welcome to our introduction to solving equations using addition and subtraction. And today we're going to start with a review of what we've been doing, which is simplifying expressions. When we simplify an expression, we create fewer terms, known as combining terms, or we release the parenthesis, which we use distributive property with. We do not find the value of the variable. And so this has been uncomfortable when we first started because it doesn't look like an answer when we get done. But what we create is an equivalent expression. So we're going to start by multiplying -4 times w. That -4 again multiplies everything inside the parentheses. So this is going to become one term in a minute. Then I go back to the -4 times -9. -4 times -9. And this will become a second term. So -4 times w will be -4w. And then a negative times a negative is a positive. So this is going to become positive 36. And this is the answer. It's an equivalent expression. And when we simplify expressions, we don't get what looks like an answer. We get an equivalent expression again. So let's now investigate what happens in the second example. In order to create an equivalent expression here, I need to combine like terms. So these two terms are like terms because they both have the variable x. And I'm going to choose to use this minus 2x as a negative 2x. So those are considered like terms. Next, I'm going to go and I'm going to gather up the y's. This minus 10 I'm going to use as a negative 10y, and this plus 4 is going to be a positive y. So I've gathered my like terms. When we work with combining them, we're using the coefficient, the numbers in front of the x's, and combine means we're adding. So I'm adding a -5 and a -2, and this together will become -7x. For the second pair, I'm using the coefficient of 10. The coefficient is a number in front of the variable, and since I'm combining, I'm going to add positive 4. -10 plus positive 4 is -6. So I'm going to drop that down as a -6, and I also need to include my y. Now we could write it as -7 plus -6y if you prefer. But this is the preferred way to write it because we don't have double signs. We just have one operation sign. So that's what we've been doing for the last couple weeks. So now let's go on to our new topic. Solving equations. When we solve an equation, we find the value of the variable. This is known as the solution. We accomplish this by using the opposite, what's known as the inverse operation, than the one that is given in the original equation. So I see that we're adding here, and so the inverse or opposite of adding is going to be subtracting. But before we get to that, I'm going to ask you to just use your reasoning skills, and I want you to tell me if you can figure out what the value of x would be in order to add 8 to it and then get back the result of 20. So if you said that x equals 12, you're correct. So x equals 12. And so finally, this looks more like an answer. This looks like an answer we're used to getting. And let's prove that it's 12. So if I replace the x with 12, and I added 8, it would indeed give me back 20. So this is called a check. And when we write what x equals, it means that is the solution. And when we write a solution, we need to include the variable and the number that makes the equation true. So let's try that again using our reasoning skills. In example 2, we want to figure out what number we could replace a, or what number a represents if we subtract 10 from it to get back 17. So what number could we fill in for a? So A would equal 27. So again, this is the solution, and let's check it. 27 minus 10 would give us the result of 17. This is called a check. So when we work with equations, okay, when we solve equations, solving equations means we figure out the numeric value, the number for the variable. In order to do this, we need to isolate the variable on one side of the equal sign and isolate the numbers on the other side of the equal sign. A solution looks like these examples. So x, or whatever variable we're working with, can be a positive number. It could be a negative number. The variable could also be a fraction or a decimal. And sometimes it's written this way. We see the number on the left side and a variable on the right side. But it still means the same thing. The number that represents B is 11. So please go on to the back page. So before we begin, I just want to let you know that if you haven't solved an equation before using the steps that I'm going to teach you, it's going to be a little bit uncomfortable because anytime we try something new, it's uncomfortable. But you're going to need the steps that I'm teaching you when you solve more complex equations. So I want you to realize that sometimes we can't solve an equation by just using our logic. We need to learn the steps for solving. So please do this with me. So let's read through this, and this is just going to take practice. So don't give up before we start. Just go ahead and know that this will take us practice to learn this. So when we learn to solve an equation, we do this by undoing any operation and constant next to the variable. For addition and subtraction, this undoing is called the additive inverse. As long as we do the same operation on both sides of the equal, we've balanced our equation. So I'm going to ask you to start by creating a line, which I'm going to refer to as a wall, down the middle of the equal sign. So that's our where we're going to balance the equation, our fulcrum. So if I look at what I'm given on the left side, I have a, the variable, plus 7, so the constant. And it says I'm going to undo any operation by using the inverse. An inverse is opposite. So I want the a by itself. I just want a on the left side. So if I have a plus 7, or I can look at it like it's a positive 7, I'm going to use the opposite, which is minus 7 or negative 7. So I'm going to write that. But whatever I do on the left side, I must do that same thing on the right side. So in this way, we balance the equation. What is done on this side is done on this side of the equal sign. And we put the line down to remind us that's what we have to balance. We have to go have same thing on both sides. So here's what this accomplished for us. If I added 7 and then subtracted 7, I would have 0. Or if I had plus 7 minus 7, I have 0. So when we worked with the integer chips, we called that zeroing out. This is no longer here. But what is left over is the a. So we've isolated that variable. We want to know what a equals. And so on the right side, 39 minus 7 would be 32. So we have accomplished finding the solution. So now let's do what's called a check. I'm going to double check to make sure this works. The original equation, where a is, I'm going to replace it with 32. And then the original equation said plus 7, and it should equal 39. And if that's true, then I know that my solution is true. And this is often called a check, where we check our solution by replacing the number where the variable is. And if the answer is true, then we know that we have accomplished our goal and found the solution. So I'd like you to try one on your own. So on your piece of paper, I'm just going to use the variable y this time. And I'm going to add 6. And it should equal, let's make this 18. So what I'd like you to do is to try the same step by using the inverse of plus 6. So I'll pause and let you try that. So we start this process by building a wall, or building a line to separate the left side from the right side. And I always start on the side that has the variable. So this left side has the variable. I see y, our unknown number right now, plus 6. So the inverse, the opposite of plus 6, would be minus 6. Or if you prefer to think of that as a positive 6, I'm going to do negative 6. But whatever I do on the left side, I have to do exactly the same thing on the right side. So what this accomplishes is this becomes 0. They undo each other. This is a 0. But what I have left is the y on the left side, and on the right side, I have 12. So we think the solution is 12. So let's check it. If I replace y with 12, and then I add 6, which is what the original equation says, does that equal 18? Is that true? Well, it is. So that means our solution is correct. So our original first problems had addition, and the nice thing is this same process works for subtraction. So let's try number 3. So the same process. We're going to build the wall down the equal to remind us whatever we do on the left, we have to do on the right. We're going to locate which side the variable's on. It's on the left side, so that's where I'm going to start. I need to undo minus 12. So I'm not trying to undo 50. I'm trying to basically get rid of minus 12 because I want to isolate that variable by itself. So the opposite of subtracting 12 would be to add 12. Or if you want to think about this as negative 12, then I need a positive 12. But whatever I put on the left side, I must do exactly the same thing on the right side. So what this accomplished for us is we now have zeroed out the 12, leaving my x. So the purpose is to isolate the variable, to get the variable by itself. So now, on the other side, if I complete my math, I have 50 plus 12, and that's 62. So we think the solution is x equals 62. So we're going to check it. We're going to replace the x with 62. The original problem says I'm supposed to subtract 12, and that should be 50. And sure enough, that's true. So we know that we found the solution. So now what I'd like you to do is I'd like you to try a problem on your own. So we're going to use, this time let's use W, and we're going to subtract 5 from that, and that should give us back 11. So would you try that? Pause the video and try it on your own, please. All right, we're going to start our process. Again, we want the wall to remind us whatever we do on the left, we do on the right. The variable is on the left-hand side, so this is where we start. We want to undo minus 5, or negative 5. So the opposite of minus 5 would be to add 5. So we're going to add 5 on both sides. This always must look exactly the same on both sides. So it's balancing the equation. So what occurs next is that these 5s, by adding 5, I've undone the minus 5. So we no longer have 5, but our variable is left over. That was what we wanted to accomplish. And on this side, it's equals 16. So we think the solution is 16. Let's check it. If I replaced W with 16, and then I subtracted 5, I would indeed get back 11. So our solution is correct. So we're going to stop here for today, and next time we're together, we're going to practice this type of problem, the type of problems we just completed. We'll get to the other problems on the page also during that day. So I don't want you to get discouraged when you first work with solving equations. It seems like a very odd concept, but I'm hoping that you learn to love it like I do. Take care.